This question is a start question, so it's expecting a lot of workings out and some clear steps that you take. And when we read the question carefully, it talks about could Kirsty's average speed. So straight away we're thinking speed equals distance divided by time. So that's going to be part of our workings out. And it's talking about an average speed limit, and it wants to be greater than that. So it's starting to use these words greater, but it's also in the question used the word nearest. So it's kind of implying there's been some rounding going on, and it wants the greater, so it seems to be implying that it's going to be about bounds, upper bounds and lower bounds. So as soon as you see those key ideas in a question, then you're thinking to yourself, right, the distance has been rounded, the accuracy that's been given is nearest 10 meters. So the error, and this is all about the bounds, what could have been the smallest distance possible, what could have been the largest distance possible. The error is always a half of the accuracy, so the error is going to be plus or minus 5 meters. So a half of the accuracy, that's what the error is. So that allows us then to write down what the lower bound of the distance is and what the upper bound of the distance is. And this will give you at least a method mark in the exam by finding those things. So the lower bound is going to be 5 meters below what they gave. Now they gave an answer of 4530, so the lower bound is going to be 4525, and then the upper bound will be adding 5 meters on. So the upper bound will be 4535. Now just remember why that all worked. Somewhere along the line they've been using a scale to do their measuring, and they've been measuring in tens, and somewhere was 4530 on this scale. The one below that, 10 below, would be 4520, and the one above that would be 4540 in meters, of course. And between them there's some boundaries, and whatever the distance really was, it's been rounded to this. But there must have been a case where it might have been rounded to that, or it might have been rounded to that, and they're the halfway points. And we can see that halfway between there is 4535, and halfway between there is 4525. Now technically we should put a little less than sign there, because we should realise that if it was 4535 exactly, then we would have rounded up to 450. But it is a boundary, so we allow that to be called the upper bound. It's a boundary. We do a similar thing then for the time. Now they told us the time was 205 seconds, correct to the nearest 5 seconds. So the nearest 5 seconds tells us the error is plus or minus 2.5 seconds. Error is half the accuracy, so the lower bound will be 2.5 seconds below what they give, and the upper bound will be 2.5 seconds above. So for the time, then we've got a lower bound of 202.5 seconds, and the upper bound is 207.5 seconds. So those will be the upper bounds and lower bounds for the distance and the time. It's asking us to check could the average speed have been greater than 80 kilometers per hour. So the first thing to do is work out the speed in meters per second, and then we'll convert it into kilometers per hour in a moment. So speed was the distance. Now we want to look at the greatest speed. So to get the greatest speed, then we're going to need the largest distance divided by the smallest time. So we're going to divide by 202.5. In doing that calculation we'll end up with the largest possible speed. So 4535 divided by 202.5 equals, so that's 22.39506.173. Not rounding at this stage because we want to work out the time in hours and the distance in kilometers, but we recognize the units of this is meters per second. So at the moment we've got meters per second, but the question is asking us to compare kilometers per hour. So what we need to realise is that we have to do 22.39506.173 times 3,600 seconds. That will give us the number of meters in an hour, and then we divide by 1,000 because of the conversions that we're going to use. So 1 kilometre is 1,000 metres, so that's why we divided by 1,000, and 1 hour is 3,600 seconds, so that's why we times by 3,600. So we do that calculation, so times by 3,600, divide that answer by 1,000, and we write that answer down sensibly to 3 significant figures, so 80.6 kilometres per hour. So this is the greatest speed possible. Again, start question, so we really ought to be clear what we're doing. So the greatest speed possible was 80.6 kilometres an hour. The question said, could Kirsty's average speed have been greater than 80? Well, we can see that 80.6 is. So the final answer, because of the staff to get the communication mark, would be to say Kirsty's speed, it's average speed of course, so Kirsty's average speed could have been over 80 kilometres per hour. That's our conclusion, based on the fact that we found that the greatest possible speed was 80.6 kilometres an hour, rounded to 3 significant figures. So key ideas again then guys, it was about recognising keywords in the question. They mentioned the word nearest, they wanted greater, so they're giving you the indication that this is going to be about boundaries. So we recognise the formula for speed is distance divided by time, so we needed to find out the greatest distance, the smallest time possible. That would allow us to calculate the greatest speed, and we went through using the idea that the accuracy was 10 metres for the distance, so the error is always a half of the accuracy that you use for whatever unit it is, and so the error was plus or minus 5 metres. So in other words, this measurement could have been as low as 4525 and as high as 4535, etc. So that's how that question could have been answered, literally recognising it was about bounds, and then go through the calculations in the appropriate way, and that would have allowed you to get the full marks.